We are back. This time it's rocks. Rocks from minerals. The continuation of our investigation of the geosphere. Questions that will guide us on our journey through rocks. How do they form? And how do they differ from one another? How can we say that any particular rock falls into a particular category? What are those categories? To begin with, a definition. A rock is a naturally occurring, solid aggregate. It's a word I asked you to know. Aggregate, meaning a mixture of one or more minerals or mineraloids. What's a mineraloid? That's a mineral that does not have any particular crystal form. It's somewhat amorphous, doesn't have perhaps the unit cell that we've discussed. The minerals that form rocks can be bound together by solidification of magma or lava. From lava, from magma. They can form from heat and pressure, transforming one type of rock into another. This is a metamorphic rock that had once been a sedimentary rock. Or, finally, you can have a rock which is just sediments that are glued together, compressed under the pressure of earth above them, and the formation of often a calcite cement that holds grains of sediment together in a sedimentary rock. Just to give you a sense of the grandeur of rocks, these are rocks that you could find if you were traveling out west in the United States, in Arizona, near the Grand Canyon. These are two different types of sedimentary rock. This large formation up here that is slowly eroding away, the erosion, the falling down of the rock by gravity, mass wasting. You can see the scale here. And then a second formation of sedimentary rock that you can see formed in layers. Layers that were deposited probably in water at some point in the distant past. So, I would ask you now to find the rock cycle in your Earth Science reference table, and in finding it on page 6, you have to go to page 6, top left corner of page 6, answer these questions on the worksheet that I have given you. 1. How do igneous rocks form? 2. What must happen to an igneous rock for it to turn into a metamorphic rock? And what must happen for a sediment to turn into sedimentary rock? So, we can go through those things because we have the rock cycle right here. This is that rock cycle as you would see it, page 6 of the reference table. It may be cut off a little bit here. This word is melting. This is magma, which is the beginning. In this case, on the Earth, there's really no what came first, the chicken or the egg, the metamorphic rock or the sedimentary rock or the igneous rock. The igneous rock had to come first because the igneous rock is formed from melted, in this case, stellar matter that has cooled as it's moved away from the sun in that early period of our solar system's history that is known as the nebular period, or the nebular hypothesis, where gas is moving around a density of matter in the middle and out of that forms a sun, and some matter is left over that escapes the sun's gravity, and that will form the planets of our solar system, the asteroids of our solar system, the comets of our solar system. And our planet forms of material that will become the rocks. And that initial material is essentially magma made of a suite of 92 elements that become the earth. The magma does its first thing to change, and that is to cool and solidify. They could put the word cool here. The magma is hot, it cools and solidifies, and it becomes an igneous rock. Then, that igneous rock can be exposed through the history of the earth to the atmosphere, H2O in liquid, solid, and gaseous form, and it can be weathered, changed into smaller particles that we call sediments, which can then form sedimentary rock. And we could take either an igneous rock or a sedimentary rock and turn it into a metamorphic rock when, in certain locations, certain environments on the earth, there is, near the surface, enough heat and pressure to actually transform what had been an igneous rock into a new type of rock called metamorphic. Meta meaning change, morphic meaning shape. Sedimentary rock, changing from sediments that were loosely glued together to crystalline rock that has formed from heat and pressure. And finally, a metamorphic rock that already exists could be remetamorphosed and turned into yet a different metamorphic rock. So all around the cycle we go, starting though with magma. The percentage of the three rock types on the surface of the earth, you can see igneous makes up more of the rock than any other. Much of that is the surface of the ocean basin, which is basalt and perhaps some gabbro. No, the gabbro isn't really, well, I'm not sure exactly about the ocean basin with gabbro. I don't want to say. Then you have continental crust, which is typically these granitic and intrusive rocks and extrusive volcanic rocks, which we'll talk about in a moment. Then you've got a little more than 25%, those types of rocks that have been changed from another rock, metamorphic, and then sedimentary rocks, which are made from the sediments of any other rock. How do igneous rocks form? We begin with the beginning. Igneous rocks form from molten liquid, magma under the earth, lava near the surface that cools and solidifies. This was lava that cooled and solidified. This rock formed from magma that cooled and solidified. The rate, the amount of time it takes for the cooling to take place, short, rapid, or long, slow, that rate of solidification, that rate of cooling determines the rock's characteristics. Everything depends on how long it takes to cool. And of course, things that cool near the surface cool quickly, and things that cool deep in the earth tend to cool slowly. The parent material for all igneous rock is magma, but you should know that magma that is released directly onto the surface of the earth is called lava. Magma in the earth, lava near or at the surface. Magma consists of three different phases, like any form of matter we're familiar with on the earth. Liquid, or the melt, is composed of mobile, that means they can move, ions of different elements. So you can have ions of iron or magnesium and silicate that are in the melt, and slowly by cooling become, or quickly by cooling, become a mineral that makes up a rock. These ions then, the ones that are the most predominant in magma or lava, are silicon and oxygen, forming the silicon tetrahedron, aluminum, potassium, calcium, sodium, iron, and magnesium. These are the most common rock-bearing mineral elements. The amount of silica will influence the behavior of a magma or lava. High silica content, SiO4, silica tetrahedron, means that the magma is viscous, moves slowly. Low silica content, low viscosity, means that it's runny very fast. Continuing the phases, we have a solid form of the lava or magma, which is determined by the rate at which it cools, therefore giving us the size and number of crystals increasing the more it cools. And of course, any magma or lava is releasing gas. Some of those gases would include water vapor, carbon dioxide, sulfur dioxide are the most common released by lava or magma. So all three phases are involved in a melt, either deep in the earth magma or near the surface lava. Classification of igneous rock starts with the environment of formation. Where did that rock form? Extrusive means it formed at or near the surface of the earth, and we consider that to be volcanic rock. Intrusive, forming inside the earth, also known as plutonic, of the lower world, the god in Latin mythology, Roman mythology, Pluto, form from magma that cools into what is known as a batholith, or laccolith, or stock, or dike, or sill. These are intrusive igneous rock structures that form under the earth. I will add that with laccolith, stock, dike, or sill, it is possible to form an extrusive rock if it's close enough to the surface. Intrusive igneous rocks, the crystallization depends on the rate at which the magma cools. This says depends of, it should say depends on. Sorry about that. In this sample of granite, you can see individual minerals. I can say the same about this sample of granite, and this sample of granite, this sample of granite. Oops. This sample of granite, very weathered, but you can see individual minerals. Below the surface of the earth, magma may cool over a period of hundreds to thousands, tens of thousands, hundreds of thousands, even millions of years. It can take a very long time for a magma chamber to go from the liquid state to the solid state and become what we call a batholith. There is your batholith that has formed and is now solidified with a dike moving up towards the surface, where perhaps you have fine-grained igneous rock here, more like an extrusive rock, and down here, large crystal intrusive. Here's your sill, a horizontal movement of magma or lava in the ground that melted through existing rock and ended up as sort of a sill under the earth. The stock is just magma that moved out of the batholith, melting and created its own little chamber. The laccolith is a formation that is pushing up and shifting the surface of the earth above it. And this could also have fine-grained igneous rock, which we might consider extrusive, as we might hear in this volcanic neck. So this batholith and batholiths anywhere on Earth can be exposed over time if these... Oh my God. We know that sound. It doesn't happen every time you watch one of my great videos, but this time it has. I'm going to turn it off. It's a signal that this is about 15 minutes long, and I think that that's just where we'll stop after I tell you two more things. One, this batholith, solidified, intrusive igneous rock, can be exposed under certain conditions when the forces of plate tectonics, for instance, can press this entire formation up into the air higher and higher, and therefore these layers of sedimentary rock or metamorphic rock can be weathered away, eroded, exposing the batholith. This is one of the most famous batholiths in the world, exposed above the surface of the earth, Sierra Nevada mountains, Yosemite National Park, Yosemite Valley, as photographed, I believe in the 1930s or 40s, by a great American photographer, Ansel Adams. And with that, we'll take a break.